Welcome to the Mind Spark, bringing you the latest news from around the world. Imagine looking up at the night sky, countless stars, each a distant sun, twinkling quietly above us. For millennia, humans have gazed upward, wondering about the mysteries hidden in that vast expanse. But what if you could see even farther, beyond the stars of our own Milky Way, to the vast ocean of galaxies that stretch across the universe? Each one is a swirling island of billions of stars, separated by unimaginable distances. Astronomers recently discovered something truly bizarre: several galaxies separated by millions of light-years, all dimmed at the exact same time. This wasn't just a coincidence or a minor fluctuation. This wasn't a subtle change, it was a dramatic synchronized drop in brightness, as if the universe itself flicked a cosmic switch, plunging these galaxies into a mysterious shadow. According to the laws of physics, nothing can influence another galaxy faster than the speed of light. Information, energy, and matter are all bound by this universal speed limit. Yet these galaxies dim together, defying everything we know about how the universe works. It's as if they were somehow linked by an invisible thread. Scientists first suspected a massive dust cloud passing in front of the galaxies, or perhaps a glitch in the telescope's instruments, but those explanations didn't hold up under scrutiny. The data was consistent, and the effect was undeniable. Multiple observatories around the world confirmed the dimming was real, ruling out equipment error or local interference. The galaxies are scattered across the sky, separated by vast distances, making a single local cause impossible. The universe had presented a puzzle with no logical solution in our current framework. It was a cosmic riddle that challenged our understanding. This is where science gets truly exciting. When we hit a wall, we know we're on the verge of a breakthrough, standing at the edge of the unknown. The synchronized dimming isn't just a minor anomaly, it challenges the very foundations of cosmology and the principles we thought were unbreakable. It forces us to ask, could there be a hidden principle at play, a connection that operates outside known physics, something that links these galaxies in ways we can't yet comprehend? The universe, it seems, is far stranger and more mysterious than we ever imagined, full of secrets waiting to be uncovered. And this mystery is just the beginning, hinting at discoveries that could change everything we know about the cosmos. Faced with this mystery, scientists did what they do best. They tested every possible explanation. Gravitational lensing? No. It would brighten or distort, not dim galaxies across the sky. Dark matter or dark energy? Maybe, but there's no mechanism to explain such perfect synchronicity. Every conventional idea hit a dead end. The problem is scale and speed. Nothing should connect galaxies millions of light-years apart instantly. The simultaneous dimming violates the principle of locality, suggesting a non-local connection that unsettles physicists. Some hope for a mundane explanation, using AI to sift through data for hidden patterns. But others, myself included, think we need to look to the strangest, most successful theory in science: quantum mechanics. The rules that govern the tiny world of atoms might hold the key to this giant cosmic puzzle. When our theories fail, we must be bold enough to consider radical ideas. The universe may be whispering a secret, and we need a new language to understand it. To solve this cosmic mystery, we must dive into the quantum world, a place where the rules of everyday life no longer apply, and the very fabric of reality seems to twist and turn in unexpected ways. This is the realm of atoms and photons, where reality gets weird and the impossible suddenly becomes possible. Here, particles can be in two places at once, and events can happen without a clear cause. One of quantum mechanics' strangest principles is the observer effect. Just observing something changes it. The act of looking, of measuring, actually alters the outcome. Before you measure a particle, it exists in a cloud of possibilities, a wave function, a mathematical haze of all the places it could be. Only observation forces it into a definite state, collapsing all those possibilities into a single reality. Think of a spinning coin. It's both heads and tails until you catch it and look. The outcome is undecided until the very last moment. In the quantum world, particles are like that coin, uncertain, existing in a superposition of states until measured. This isn't just theory, it's the foundation of technologies like lasers, computers, and even quantum cryptography, which rely on these bizarre effects. Even Einstein resisted this idea, famously calling it spooky action at a distance. But experiments proved him wrong. The observer is part of reality's creation. The big question: what counts as an observer? Is it just conscious beings? Or can machines and even other particles play this role? A human? A device? Any interaction at all? The debate continues. And the answer could reshape our understanding of reality. The observer effect is fundamental at the smallest scales, influencing the tiniest building blocks of matter. But what if it isn't limited to the microscopic? What if these quantum rules ripple outward, affecting the universe on the grandest scales? What if it shapes the entire universe, guiding the evolution of galaxies, stars, and even the fate of everything that exists? If faced with a cosmic mystery that defies all else, maybe it's time to consider that quantum rules play a much bigger role in the cosmos than we ever imagined. Let's take this quantum idea and apply it to the universe itself. What if the cosmos is described by a single gigantic wave function, existing in a sea of possibilities until observed? When we point powerful telescopes at distant galaxies, could our observation collapse their wave function, forcing them into a definite state? The synchronized dimming might be a side effect of this cosmic scale collapse. The galaxies aren't sending signals. They're part of one interconnected quantum system responding to our measurement. This flips our perspective. We're not just passive observers, but active participants shaping reality. Our act of looking might actually influence the universe we study. The universe isn't a static stage. It's a dynamic system that responds to being watched. We're not creating galaxies with our minds, but our observation might finalize their properties. The synchronized dimming could be the sound of cosmic dice landing, simply because we decided to look. It's a breathtaking thought, our consciousness connected to the fabric of the cosmos. There's another idea gaining traction, the simulation hypothesis. It suggests our reality is part of an advanced computer simulation, with the laws of physics as its code. Simulating an entire universe at once would require impossible computing power, unless the simulation only renders what's observed. Like a video game, the universe might only load details when we look. The observer effect fits perfectly. A particle's state isn't calculated until measured. The synchronized dimming could be a sign of the system rendering new details as we observe them. We can't prove or disprove this yet, but some scientists are searching for clues like glitches or a fundamental pixel size in space-time. The possibility is profound and it's too intriguing to ignore. Let's stick with the video game analogy for a moment because it offers a surprisingly powerful way to understand some of the universe's deepest mysteries. In open-world games, the world feels vast and immersive, but in reality, only the area you're currently exploring is fully rendered in detail. Everything else is just a rough outline or a map, waiting in the background until you get closer. The universe might operate in a similar way. Details of reality aren't fully calculated or rendered until we actually observe them, just like a game engine saving resources by only showing what's needed. Before our telescope points at a distant planet, that planet might exist only as a set of probabilities or potential outcomes, not as a definite object with fixed features. When we finally look, it's as if the cosmic computer renders those details in real time, collapsing all those possibilities into a single concrete reality that we can observe and measure. The synchronized dimming of distant stars, for example, could be the system allocating its computational resources to render that particular part of the cosmos, just as a game engine does when you enter a new area. In video games, the contents of a treasure chest aren't determined until you open it. Similarly, in quantum physics, a particle's properties aren't set until they're measured by an observer. The universe, then, could be seen as an interactive experience, generated in real time by our observation and participation, making us active players in the unfolding of reality. This idea doesn't make life meaningless. If anything, it highlights how our experiences and choices are still deeply real and meaningful to us, even if the underlying mechanics are different than we once thought. The simulation hypothesis simply reframes the nature of reality, suggesting that the universe's hardware might be computational, and that what we perceive as physical is actually information being processed. It's humbling, and a little mind-bending, to think our existence might be code running on a cosmic computer, and that we're only just beginning to notice the pixels at the edge of our reality. These cutting-edge ideas echo ancient beliefs that the universe is a living, conscious entity. Many cultures saw reality as interconnected and aware, with our consciousness as a small part of a greater whole. Today, physicists talk about the observer effect and cosmologists consider a universe that responds to our attention. Science and mysticism, once opposites, are converging on the idea that we're deeply entangled with the cosmos. The language has changed. Universal wave function instead of world soul, programmer instead of great spirit. But the core idea is similar. The universe isn't just dead matter, It's a dynamic, responsive system. The mysterious dimming of galaxies could be the first scientific evidence that ancient intuitions were right. Science and mysticism might just be climbing the same mountain from different sides. We stand at a remarkable moment. Evidence from quantum physics to dimming galaxies suggests a universe more interactive than we imagined. If the cosmos is aware of our gaze, what's our role? Are we audience, actors, or something more? If we're in a simulation, who created it and why? To study us, to learn, or for entertainment? Even without the simulation theory, if consciousness shapes reality, what does that say about our power? Our scientific journey might be an act of creation, turning the universe's potential into reality. The synchronized dimming is a clue, a breadcrumb leading us deeper into existence's mysteries. As we look to the sky, it seems the universe is looking back, and what we become may be the greatest discovery of all.